everybody, I'm Leona from Intmax. Today I want to talk about statelessness, on the how it works, on the how it behaves, and how to cook it. So have you ever heard of statelessness, or maybe you heard of Intmax, maybe you know something about her statelessness, I guess. So Intmax is a stateless layer of Ethereum. And you can believe that this is surrounding the stateful network, including our Ethereum layer 1 or the other rollups. It's providing the extreme scalability and privacy at the same time. So statelessness is something mysterious. Sometimes it works like a privacy coin like Monero or Gcash, and sometimes it's like smart contract platform. Sometimes it's like a payment system or app-specific chain. Sometimes it's general. So I want to invite you to the rabbit hole of statelessness today and how it works as a transfer layer of Ethereum. So there's a trade-off, of course. Now, stateless is more and more scalable than stateful rollups and the stateful layer ones. And it's more private and less functionality. So transfer is the most important part of statelessness. And actually, we can do many things with these transfer functionalities. So if we do the conditional payment, we can use a smart contract to process the payment in certain conditions. It makes our DEX, it makes our NFT marketplace, it makes our, many stuffs are with that. So if we talk about the architecture, or relationship with the other networks, it's like surrounding or the Ethereum ecosystem with the stateless payment layer or transfer layer. So rollups and Ethereum, they have more functionality with certain state and the conditions. And basically, Intmax is more interoperable and it's more unstoppable, private, extremely scalable. Why stateless layer is so scalable, we can summarize that is because by its definition, it's all about posting the minimized constant data on chain. In a narrow definition of in cryptography space or cryptography, financial cryptography, the statelessness is all about the minimum data, constant minimum data on chain. And it means that you don't have to get annoyed by the fluctuation gas fee, because no matter how many people come to in one network, it's constant cost on chain, right, in terms of data cost. So surrounding stateless layer helps there many use cases, privacy, interoperability, and constant gas cost, eliminating the fluctuating gas fee. So this is a clear comparison with each other. So we can describe this trade-off between statefulness and the statelessness in a more detailed way. So there are many scalability solutions, right? So for example, Intmax 2 and Plasma Next is coming from Intmax. It's more focused on statelessness. Lightning Network is our most famous scalability solution in Bitcoin space. Plasma is well discussed in 5 years ago, or something like that, 2018. And rollups, it's booming, the maturing right now, right? So in terms of this comparison, I don't say it's kind of 100% fair, because sometimes we need to add the privacy, which Lightning Network and Intmax have. Sometimes our rollups have more functionality, so we need to add that. So yeah, I don't think this triangle describes everything, but basically, in terms of most important part, the basic US, basic safety and the scalability, it's all about statelessness and the capital efficiency and offline safety. If you have an offline safety, you can have, you don't have to run node to keep yourself safe. If you have capital efficiency, you can, spend your own money instantly after you deposit, right? Statelessness it's all about scalability. They're posting their minimized data on chain. So this triangle is quite important to have the essential scalability of blockchain. And in terms of that, Intmax 2 Plasma Next have a very good triangle. The Lightning Network, it has it's a great scalability, but capital efficiency and offline safety is quite challenging. And rollups, they have a quite good UX with capital efficiency and good offline safety, but it's less scalable. Oops. Oh. Okay, so I want to introduce briefly how to cook statelessness. It's like first step one. We need to have a communication between block producers and the user side. User side receives their macro proof as their UTXO. So each macro proof given by operator or block producer is UTXO. UTXO itself is a macro proof, and you can input that in the ZKP circuit off-chain, and basically you can sign back to the block producer to prevent skipping this procedure. Then basically it's making sure that you guys can have your data on your client side. Then this is how to make safety in this communication compared with ZKP and block producing on chain. So proof update, it's like in this communication. And once you are given the proof, you need to prove that your proof is not spent after that, right? And basically we can apply the no transaction proof after you were given the macro proof by block producer. Then you can prove that you didn't spend your money after you got this proof. Then this proof is still valid after your block is after the block is changed, or after we have a new block or state. So surprisingly, basically it makes only 5 bytes data on chain for each transaction. And each transaction, you can increase 10,000 transfer to that 5 bytes transaction cost without any additional data. Now this is quite a big achievement we had for this to make this stateless payment layer. And how to make sure that your UTXO given macro proof is safe. You can prove that it's not spent after that, but your kind of incoming transaction or incoming UTXO, how to make sure that it's safe and it's true money. It's an endless chain of the balance proof, right? Your UTXO is coming from another person, and another person got that from another person, right? It's an endless chain of transition of UTXO or the ownership of UTXO, right? So we can, in some client-side verification or client-side or validation project have infinite lengths of this verification actually, and how to make it efficient enough to be practical. So we can obviously apply the recursive ZKP, right? This is the endless recursive ZKP. So in this architecture, so basically you can think that ZKP n-2 is proven in n-1, and the ZKP n-1 is proven in our ZKP n, and this is our endless chain of ZKP, right? So once you verify the previous ZKP, this proves the entire history of ZKP at the same time, right? So because it's already proven the previous one, and the previous one already proven the previous one, previous one, right? So this chain of ZKP is extremely efficient way to verify the entire history of UTXO. Once you verify the previous one, simultaneously it means that you verify and prove that entire history of UTXO and the entire history of ZKP chain is valid. So coming back to the previous slide, it's the endless chain of ZKP and the endless chain of the UTXO pass it off-chain, nothing go on-chain, and this goes simultaneously on each client side. So if there are million users, million level parallelization. If there are billion users, billion level parallelization happen in each client side. So yeah, I want to make it short. So yeah, the last advertisement is like, one transaction you can increase an almost unlimited number of transfers in one transaction without adding any on-chain data. Basically, it's constant, and you can prove, aggregate so many transactions. And everything will be totally private, and everything will be totally peer-to-peer. So this is the construction and the surprising result which we made. And at the last, we need to say that how we are base rollup. And what is base rollup? Yeah, basically Justin Drake come up with this idea, and according to him, our team found the concept of base rollup independently a bit later than him. And basically, Intmax 2 is base rollup, and base rollup means that it's interoperable with the other rollups, especially the other ZK rollups, base rollups. So basically, concept of base rollup is making many layer 2s one big layer 2, and it's the most, recently I found that it's the most exciting idea in this space as well. And base rollup is like, uniting the mechanism in layer 2 space. And Intmax is originally, Intmax 2 is originally base rollup, meaning that it's interoperable with the other chain, and once you verify or send a transaction in this Intmax 2 rollup, you can transact with the other smart contract on the other base rollup. And it's more like an academic side take on the statelessness. I said so many things about the statelessness, and I said it's great. And at the same time, there's a criticism that it's impossible. And basically, what they are saying is totally correct. And they are saying that these red lines, and basically it's meaning that, let's say, stateless system needs frequent local proof update. And the local proof update sometimes it's quite annoying, and sometimes it's not so annoying, or it's quite harmless. And in our architecture, a local proof update is quite harmless. So basically the main direction to solve this problem is like making local proof updates less harmful or critical or totally harmless. And in our system, it's almost it's just make a 5-second delay in our communication between block producer and the transaction sender. So basically, they're quite solved in our development. But yeah, please remember that stateless is kind of possible in some conditions, and Intmax is avoiding this problem. Okay, at the last, we are doing the privacy mining right now. So I said like stateless architecture have a strong feature of privacy, and it brings the privacy to layer 1 at the same time right now. So once you verify, once you deposit money to our contract and withdraw our contract, basically we don't have any links between them. Nobody can see the links between them, right? And we are rewarding that mechanism, and the more and more people come into this privacy mining, more and more anonymity set, the greater anonymity set we can have together, right? So it's a very big social experiment for me to do, simply because it's something new to kind of enabling people, they're making people able to buy anonymity set, right? And it's a chance for the market to buy anonymity set instead of paying their transaction fee or in their privacy protocols. And it's a new kind of way to find the price of privacy. And we cannot define the price of privacy today, but it's an experiment to make an equilibrium in the market to find out how much do we need to pay for the anonymity set. So please join this social experiment and of course get rewarded and please make your asset private in this program. So this is just an invitation, and it's a bit independent from the stateless stuff, but yeah, I'm doing this passionately, so please join this. And thanks for listening to me today, and yeah, the thing's done.
All right, thank you so much, Leona. We have one question so far, so please don't forget, if you have any questions for Leona, please scan the QR code and enter the question. But let's start with this one. So given the huge difference with general L2s, is the expectation like users to use others usually for executing contracts and spending Intmax when they want to simply transfer a lot and or with privacy?
So yeah, a bit are taking time to understand this question, but basically, yeah, of course, it's a huge difference between the general contract execution in other layer 2s and the basically sending a token Intmax. And the Intmax provides a conditional payment, so sometimes it's make our execution of smart contract, but it depends kind of. No, it's restricted to conditional payments, which means that you cannot lock the token on smart contract like Avi or Uniswap and these kind of stuff. And it's more, of course, it's private. And so, expectation. So basically, we are expecting that people use this for extremely cheap payments with smart contract condition. And yeah, that's their expectation. So yeah, I think it's quite correct understanding.
Okay, thank you. And the second question would be how to manage higher computation requirements and potential latency in transactions.
So higher computation requirements, and yeah, this is quite a good question, and actually it's quite limited. So as I said, as I described in the chain of the ZKP picture, basically each ZKP is proving the entire history and its constant cost, and it takes 2 seconds in Mach M2 and the 5 seconds are in older version, I guess, and it's quite limited. So yeah, higher computation requirements it's not true actually. Yeah, basically we can think that 2 or 5 seconds or delay or latency is everything, or we can have other, we need to have other downside. And yeah, it's quite limited. And at the same time, it's getting shorter and shorter because of the evolution of machine and the ZKP itself. So yeah, the latency, 5 seconds latency makes everything, scalability, interoperability, privacy, and this kind of stuff.
Okay. Someone was able to sneak in another question. So we have how privacy mining connected to the statelessness and int.max. I would probably say, how is privacy mining connected to the statelessness and int.max?
So it's all about the making great anonymity set. So statelessness, actually it's not so connected with statelessness. Statelessness makes privacy and make the breach of the privacy application, right? So for L1 users, int.max works like a privacy application. And for the payment user or layer 2 users, it's like a payment focus app specific layer 2, right? So I think that yeah, the connection is privacy. And we need a more greater set of anonymity in terms of privacy. So that's the reason why it's somehow connected. And we need to emphasize that this token economics is quite useful for both of them, L1 users and the L2 users.
All right. Now you come with the questions. We can only have one last one, and that's it. And only a quick answer. How to bridge ERC20 token to int.max?
And just deposit. That's it.
Doesn't work. All right, then let's wrap it up. Give you a big applause to Leona.